All right, let's get right into it. Today, we are diving deep into the very heart of your computer, the component that does pretty much all the heavy lifting, the central processing unit, or as you probably know it, the CPU. I mean, have you ever really stopped to think about that? You click an icon, and boom, a program just appears on your screen. It feels like magic, right? But it's not. In that tiny little split second, this incredibly complex chain of events kicks off, and it's all being run by one single critical component. And honestly, that's the best way to think about it. The CPU is, for all intents and purposes, the computer's brain. It's the part that does all the thinking, all the calculating, and all the decision making. Literally everything your computer does has to go through the CPU first. Okay, so we're calling it the brain, but what does that actually mean? What does being the brain of a computer really entail? Let's break down its most important jobs, the core things it has to do to make everything else work. You can almost think of it like the super efficient CEO of a huge company. It's not just doing one thing. It's the central hub that processes all the information and it controls all the other parts of your computer. We're talking the memory, the graphics card, you name it. It handles every single calculation and makes all the key logical decisions. It really is the ultimate multitasker. Now, if the CPU is the brain, it's got to have specialized parts inside to handle different kinds of thinking, right? So let's kind of peel back the layers here and look at the two most important players working together inside that brain. So on one side, you've got the control unit, which I like to call the coordinator. Think of it as the computer's central nervous system. It's not the one doing the math, but it's the manager. It grabs the instructions, figures out what they mean, and then tells everybody else what to do. And on the other side, you have the arithmetic logic unit, or ALU. Let's call it the calculator. This thing is the number-crunching powerhouse. It does all the addition, subtraction, and all the logical comparisons like, is this number bigger than that one? So you've got the control unit directing all the traffic and the ALU doing all the heavy math. So how do these two parts, the coordinator and the calculator, actually work together to get anything done? Well, they follow this very precise four-step dance for every single instruction. This process is like the fundamental heartbeat of all computing. And this dance, it has a name. It's called the machine cycle. It's the complete end-to-end process for handling just one command. It doesn't matter if you're adding two numbers or just changing the color of one pixel on your screen. Every single action boils down to this fundamental cycle. And what's so cool about this is how logical it is. First, the control unit has to fetch an instruction from your computer's main memory, which is your RAM. Simple enough. Next, it has to decode that instruction, basically translate it from software code into electrical signals the hardware can actually understand. Then comes the fun part. Execute. The instruction gets sent over to the ALU, which does the actual calculation or comparison. And finally, that result has to go somewhere, right? So the CPU will store the answer back in memory so it can be used later. Fetch, decode, execute, store. Over and over and over. And here's the part that is just, well, it's kind of hard to wrap your head around. That four-step cycle doesn't happen once or twice. It happens billions of times, every single second. This is exactly what we're talking about when we mention processor speed, measured in gigahertz or GHz. So when you hear that a processor is 3 GHz, it means it's running that exact cycle 3 billion times a second. The scale is just staggering. But of course, it doesn't stop there. Modern computers are way smarter. To handle the crazy complex programs and games we have today, they can't just rely on raw speed. Instead, they've come up with some really clever tricks to get more work done at the same time. Let's look at how they boost that brain power. Okay, so the first huge leap forward was the idea of the processor core. The best way to think about a core is as a complete, independent brain that lives inside the CPU. So instead of having just one brain working super fast, what if you had 2, or 4, or 8, or 16 brains all working inside the same chip? That's the whole idea behind a multi-core processor. Then, engineers got even more clever with something called hyperthreading. Now, this is a pretty slick technology that basically tricks a single physical core into acting like it's 2 virtual cores, which we call threads. It's able to do this by using the tiny little pauses and idle moments in a core's workflow to sneak in a second task. So in effect, one brain learns how to think about 2 different things at once. It's a massive boost for multitasking. And when you put all of this together, multiple cores, each with multiple threads, you get this powerhouse concept called parallel processing. This is where multiple brains, all those physical cores, work together at the exact same time on one big problem. It's kind of like having a whole team of mathematicians all solving different parts of a giant equation simultaneously. This is what makes modern gaming, video editing, and all that high-performance stuff possible. So look how far we've come. We've gone from a single brain running a simple four-step cycle to a whole team of brains, where each one can think about multiple things at once. It's an incredible evolution, and it leaves us with a really interesting question to think about. As we just keep adding more and more cores and threads, what's the next big challenge? Is it simply about making them faster? Is it about improving the communication between all those cores? Or is it something totally different we haven't even thought of yet? That's the puzzle for the next generation of computer architects to solve. Thanks for joining me.